That's me, that's also me, and okay, that's enough. I like to indulge myself with a complete set of skills. However, I can't help but consider myself above everything else a maker. It all started from Lego techniques. I was fascinated by virtually every piece I've ever built. Building it myself allowed me to understand mechanisms, study them, and get that feeling of, oh boy, I made this and it's beautiful. Eventually, that evolved into 3D printing. I taught myself CAD design, which came at a cost. I started playing and experimenting with simple software like Tinkercad, then got more professional with programs like Fusion 360. This opened me to a world of new possibilities, allowing me to design, manufacture, and assemble my own technologies like these parachute and payload deployment systems that go after the name of release R and P, respectively, as well as the flight gimbal, thrust spectrum control mount. Systems that are designed to work together reliably and modularly in a wide range of advanced small rockets. Similarly, I started arranging coding blocks in Scratch to make games that made my community smile. However, as I grew and learned through courses, community discussions, and practice, my interest shifted to more practical, challenging, and long-term software. For instance, First Aid app that help users get prepared for emergency cases with intuitive and simulated lessons. iCloset, an outfit recommending app based on environmental conditions, or Epic Stream, a model of rocket aerodynamics and flight simulator that I developed after months of documented research that I plan to make available to the public. Note the pattern and you'll be able to guess what happened with the Arduino and electronic kits I used to play with in class. They soon became more complex as I designed, built, and coded my own computers. Meet Psi, a flight computer that uses its gyroscopic and pressure sensors along with PID controller algorithm that actuates the different motors of a model rocket to control its attitude and records flight data for further improvement. Now, imagine 45 Newton thrust lifting up a model rocket during 5.5 seconds as it is thrust vector controlled by quaternion-based guidance software until it reaches apogee at about 150 meters high. That's Apex Beta, whose components are tested and ready for launch, hopefully making its way to MIT's rocket team.